Okay, welcome back. This is Psychology 2 Intro, and we're looking at the second part of Chapter 1, and we're going to focus mostly on lateralization of the brain, and looking at briefly how we can see what's going on and be observant of what the brain is doing, and some brain over the time. How does the brain change over time in our own lifetime, let alone in terms of evolutionary ways. We'll look at the endocrine system as well, and we'll finish up on Chapter 1, and then we'll be able to move on to Chapter 2. Great, thank you very much. Okay, what we're looking at here, we're going to start with the second part on Psych 2, biology and behavior. And we're looking at the lateralization. That just means there's two hemispheres of the brain, the left and the right hemisphere, and lateralization just really means that. And lateralization is also about the functional specialization of the cerebral hemisphere. And you can sort of see by this diagram that there's some things that are on the left-hand side and some on the right that are different from one another, even though it controls the opposite side of the bodies. But they're also responsible for different things regarding just in terms of what we do with our lives. The left hemisphere controls the right side of the body, most functions of speech, written language, and coordinates complex movements, whereas the right hemisphere controls the left side of the body and is specialized for visual spatial. Now, visual spatial is the ability to make visual maps in your mind, putting things into dimensions and into space by thinking about them. So if you were at home and someone said, hey, I'm going to meet you at such and such a place in 5 minutes, you would need to think in your mind about how you would going to get there the quickest to manage to do it in 5 minutes. That map you made in your head and the decision you made on how to get there is visual spatial. And it also is responsible, the right hemisphere is responsible for interpreting nonverbal behavior, those nonverbal things that we see one another do, the wink, the smile. They're not words, but we need to interpret what they mean and how important that they are and what they have as meaning for us. It's also the right hemisphere that if it's damaged or in some way not whole, then attention deficit or inability to view objects in the left visual field can be an issue. So, one of the things that can be done as a way of testing is what's called the split brain. Now, this sometimes happens to persons whose left and right lateral or lateralization or hemispheres aren't speaking to one another. They don't do so in a very, they don't communicate effectively or at all. So for example, this image here is what you're seeing is that the person on the left, this person on the left was viewing this orange, and it's on the right side of the screen, then it's transmitted to the left hemisphere. When asked, what do you see? The person with the split brain might say, well, I see an orange. When the image of an apple is put on the left side of the screen and is transmitted to the right hemisphere, then because the split brain patient's left hemisphere doesn't receive the image, he might reply or she might reply, I see nothing. But they can pick out the apple by touch, moving their hand over there and touching the apple. They can touch by using their left hand, proving that the right hemisphere saw the apple. So it's quite an interesting component. In fact, what we'll find at times is that it's a rare surgical treatment that will be used for someone with severe epilepsy. During the surgery, they'll cut the corpus callosum, which is what joins the two hemispheres together, separating those two hemispheres so they create a split brain. Each half has separate sensations, thoughts, and perceptions. Now, for the person with epilepsy, a severe case, this can really reduce, in many cases, the seizure activity. It's not your typical thing that you would do. Now, when we think about the brain over a lifespan, it's an ever-changing brain. It used to be believed that the brain has a limited shelf life, that after a certain age, 50, the brain didn't develop anymore. But we have found that not to be true. Growth occurs in spurts from conception to adult life. Childhood and adolescent growth is associated with physical and intellectual advances. What a 12-year-old is capable of doing intellectually is not the same as what an 18-year-old is capable of doing. The brain is still developing, therefore it's still growing some of what it's capable of doing. Each growth spurt involves different brain areas. Age 17 to 20, the frontal lobe growth achieves the ability to plan and control emotions. The frontal lobe is the area where a lot of our central navigating occurs, where our office manager is. And so it's the element of our brain that allows us to make rational decisions and make good, effective decisions. And it's not fully developed until we're 17 and 20 years old. Gains and losses in synapses throughout life. We develop new learnings, we develop new synapses, new neurons, and we also lose synapses throughout our life. And positive influences are ongoing intellectually and motor skills training. We can continue to develop those things as we grow older. The brain does certain things, and that's in terms of this across the lifespan. And neurogenesis and synaptogenesis are when the dendrites and axons grow as synapses develop. There is an element that the brain does do what's called pruning. This is a process by which the developing brain eliminates unnecessary or redundant synapses. This is also part of what happens that if you don't use it, you lose it. So if there's skills that you're learning and you don't rehearse them and practice them, then they're not used. The brain will prune them because it's not a good effective use of them. So your learning needs to be rehearsed and practiced and used. But if you don't use it, you lose it. Myelination is a development of a myelin sheaths around the axon, and that's a growth process, and it's forever ongoing. Hemispheric specialization. Some occur early in life, and spatial perception occurs around age 8 or so. So this sort of specialization of the hemispheres occurs early, but it can continue occurring throughout life. And then brain plasticity. This is a relatively new and growing area of scientific study in psychology, and this is the brain's ability to reorganize or even reshape its response to internal and external sources. That is to say that if, for example, someone had a stroke where blood supply to a portion of the brain stops, that part of the brain dies. However, there's been many examples where people could retrain and sort of the brain reorganizes what parts of the brain take on those same responsibilities, even though those aren't the primary responsibilities of those areas of the brain. And that's called brain plasticity, the idea that brain compartmentalization may not be what we thought it was. The brain gains and loses synapses throughout our lives. Now, I'm just going to list off some of the ways in which we've been able to watch what the brain does. The EEG, the electroencephalogram. This is where it records brain activity through wave activity. CT scan, computerized axial tomography. MRI, magnetic resonance imagery. It takes high resolution images without x-rays. Functional MRIs. We also use PET scans. SQUID. SQUID is a superconducting quantum interference device. It measures magnetic changes in the brain when neurons fire. It's quite remarkable the things that we can do now and see as to what the brain is doing when it's in fact working. And the MEG is another example of what we would use. Now, the autonomic nervous system is part of the peripheral nervous system, and this transmits messages from the brain to the rest of the body. Now, if you notice the sympathetic and parasympathetic sides, these are not under control of our conscious brain. This is not under conscious control. That just means we don't think about, oh, I think I need to digest the food in my stomach. I'm going to make sure I do a good job of it. We don't have any conscious control of any of these things. These are the things that are done by the automatic nervous system. The peripheral system, sympathetic nervous system, mobilizes the body during stress and emergencies and prepares the body for action. So you look to the left side there, and you see the sympathetic. These are all the things that if we're getting ready for stress, our pupils will dilate. We don't salivate so much. We get a dry mouth. That relaxes the bronchi, increases the rate of breathing, accelerates the heart. All those sorts of things are preparing us to deal with whatever stress that we're up against. And then the parasympathetic system This is what returns the body to a normal state after an emergency. And so both these systems are very important, but this is, again, part of what the brain does to prepare us and return us back to homeostasis. Homeostasis is returning it to the way it was. And then lastly, the endocrine system. And in the endocrine system, this is the system of ductless glands that manufacture hormones and secrete them into the bloodstream to affect other parts of the body. Now, you will be familiar with some of these, and in particular, you'll be familiar with the hormones. Hormones are chemicals made and secreted in one part, and it affects another part of the body. And there's many sorts of hormones. We won't go into them, and you don't need to be familiar with all of the hormones. The pituitary gland is the master gland. And this is the gland responsible for the growth hormone and activates other endocrine glands. And then the pineal gland, which secretes hormones that controls our sleep and wakefulness. And so when we look at all the others, we have things like the thyroid gland. Some of you will be familiar with your thyroid gland. It produces thyroxine, and it regulates the rate of food is metabolized, whereas the thymus gland, it produces essential immune system functioning hormone. The adrenal glands, which sit on top of the kidneys, these are hormones that that prepare the body for emergencies and stress. It also releases corticoids and some sex hormones as well. Whereas the pancreas, it regulates blood sugar levels by releasing the hormone insulin. And the gonads, well, they're the ovaries of females and the testes of males, and they regulate reproduction and sexual functions. So I'm hopeful that you've had a bit of an insight of how complex the brain is in regards to what we think, what we feel, how we act, and that it's quite complex. It's also quite remarkable that we're able to navigate the world that we do and see the world and experience the world the way we do with a brain that has to be so very busy to keep up with what we're experiencing. I hope this has been helpful. Good luck on the rest of the semester, and please make sure you get your textbook and your notes prepared for when you do your test. It's going to come in very handy. Thank you, everybody, and goodbye.